Hi, this is Katie Baumberger, and this is my capstone project, Energy and the Solar Oven. Before I start, please note that this is not the first activity in a unit. This is the second or third activity in a unit about energy. By the end of this activity, students will be able to describe the sun's energy and how it can be collected or stored for different uses, identify materials that are capable of storing heat energy, and then graphing the data. The question will be given to the students and is, how can you design a tool or an oven to collect energy from the sun to cook food? Students will be given a list of materials to choose from and given the challenge to build a solar oven. Students will test their designs by baking some pre-made food and measure the temperature over time. This activity was found through the website Teach Engineering STEM Curriculum for K through 12. And below is the link to the activity. I did make some changes to this, including some of the materials I would give to the students and the types of things that we would be cooking. Here are a list of materials, cardboard boxes. I chose to include a variety of different sizes. In the classroom, for insulation, newspaper would probably be the easiest thing to have. Tape, aluminum foil, thermometer, construction paper, and some plastic cooking bags. I chose that instead of plexiglass because it's just more realistic for my grade level. This aligns to my STEM perspective because it takes a transdisciplinary approach. They will use their knowledge of energy from science, design and create the solar oven, technology to research energy transfer and the use of solar ovens, and math to measure and graph the temperature. Here are some of the solar oven and how it relates to the STEM principles. It would address preconceptions about energy. For Principle 2, students will watch how solar ovens are constructed and used in places around the world and experiment based on their ideas. Students will also engage in inquiry and use their own imagination, and students will engage in self-reflection and address possible modifications and improvements. And up at the top are just some of the next generation science standards that they will meet. This is a short video that students can watch. I am not going to play it now, but you can. It's just something that I would provide to them before they start. And this also came from the Teaching Engineering website, but the video is from YouTube. Here's a picture of me starting out with my solar oven with the materials I described earlier, and that's my daughter. She was helping. There was a lot of measuring, cutting, taping, and then untaping and refastening for me to get like the sides of the oven more of at an angle. My son Jacob, he made his very own oven, and then he used a plastic bag that I thought I might include for insulation as well. He decided that he would make his pan out of that, and then he made a little handle with it. There's my oven after I covered it with the foil, and then I put the loaf pan inside and covered it with a plastic slow cooker bag. I used a loaf pan, which is something I should have included in the material list to help retain the heat. There are ovens as we started. His did not have a lid. He spray painted it black, but he did put foil on the bottom. We took the temperature about every hour, and then they were recorded, and we measured the change in temperature. And you can see that the marshmallows started to puff up. That was right after an hour. And then the picture there, it showed the temperature is at 215 degrees. Here are my results, and if I would do this again, I would use the plexiglass because it would have allowed less air to travel through the oven and kept it at a higher temperature. I also could have used more tape around the cooking bag edges. And at the end, the result was the temperature in the oven actually dropped because the wind picked up and the wind could get in. So that was my solar oven activity with the help of my children. Thank you for watching.